products of whole numbers and decimals. What happens when we multiply a whole number by a number less than 1? Multiplication is always the combining of equal groups, but what happens when our groups have less than 1 in them, or when we have less than one group? As we get into today's lesson, it's very important to remember that any multiplication sign can be replaced with the words groups of. So this says 9.5 groups of 4, 5/10 of a group of 2, half of a group of 12, and 3 groups of 2. We're going to use that as we travel through finding products of numbers and decimals. The first one we have is 3 times 3/10, but we can say that 3 groups of 3/10. And here is 3 groups of 3/10 illustrated. 3 groups of 3/10 equals 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. 4 groups of 2/100ths would equal 2, 4, 6, 8 hundredths. 4 groups of 4 thousandths would equal 16 thousandths. And 3 groups of 5/10ths would equal 15 tenths. Well, what's important to remember about 15 tenths is that if these were put together, those 15 tenths makes 1 and 5 tenths. Let's keep going. Here are some of these numbers in real life. Randy bought 3 pounds of peanuts at 84 cents per pound. How much did he spend in all? And you can see that the box is drawn here for us to use to figure out this word problem. Our thinking blocks to help us solve a word problem. 3 pounds, which would mean that I would have to cut this into pounds, and each of those pounds is 84, and this is what I don't know. I don't know the total cost. So I am figuring out 3 groups of 84 cents. Is it $122? No. If this is 84 cents, then this is 122 cents. And we know that 122 cents is $1.22. Each pencil cost 23 cents. How much does 4 pencils cost? Well, let's show 4 pencils, and each of them are 23 cents. So that means that I need to figure out 23 times 4. 23 cents times 4 equals 92 cents. A giant tortoise can walk for a whole hour and only get 17/100ths miles. How far can they walk in 3 hours? Well, 17/100ths times 3 is 51/100ths of an hour. If you'll notice, each time I did that, I said the same label, 84 cents is 122 cents. 23 cents is 92 cents. And 17 cents is 17 hundredths, is 51 hundredths. It kept the labels the same. The only one that required me to do something with it was here. And I want you to be able to figure out why on this slide. Take a look and tell me what you see about the numbers in orange on both sides of the equal mark. These are all problems that we've done throughout this video. 5/10 times 2 is 1.0. 3 times 3/10 is 9/10. 4 times 2 hundredths is 8 hundredths. 4 thousandths times 4 is 16 thousandths. 5/10 times 3 is 1 and 5/10. 3 times 84 hundredths is 2 and 52 hundredths. 23 hundredths times 4 is 0 and 92 hundredths. And 3 times 17 hundredths is 51 hundredths. 12 times 7/10 is 8 and 4/10. What do you see? What do you notice? Hopefully you notice that the amount of orange on both sides is the same. Hopefully you saw that the location of the orange in all of the problems is always behind a decimal. There is one digit behind the decimal in the factors, so there's a total of 1 in the answer. 1 and 1. This one has 2 behind it, my answer has 2. This one has 3 behind it, my answer has 3. Hopefully you were able to notice so show what you know and remember to pay attention to how many digits are behind the decimal. Alright, let's see how you did. 9 times 3/10. Counting by 3s to 9 would get me to 27. But because there is one digit behind the decimal in the problem, there has to be one digit behind the decimal in the answer. So your answer would be 2 and 7/10. 9 times 12 hundredths is 9 times 12 is 108. But we have 108 hundredths, which we can correctly write if we count the digits behind the decimal and be sure that it matches in the answer. So we identify the ones behind the decimal and move the decimal that many times in the answer. This one had 1, so we moved it once. 8 times 7 is 56. Because there is 1 in the problem, we're going to move it 1 in the answer. 6 times 2 thousandths is 12. 1, 2, 3. 1, 2, 3. And when I read the problem correctly, 6 times 2 thousandths equals 12 thousandths. It does indeed make sense. Bryce bought both brothers and himself a baby bottle pop. Say that 5 times fast. For 59 cents each. How much were all 3? Both brothers and himself. So Bryce would need 59 cents times 3. So Bryce would need $1.77. 1, 2, 1, 2. The number of digits behind the decimal in the factors have to match the number of digits behind the decimal in the product.